These days you hear about green buildings and energy efficient buildings. People tell you that these buildings are water efficient apart from being energy efficient. How does this happen? What is actually done in a building in order to make it water efficient? Let's start with the density of settlement. If I have reduced in an apartment the number of families or apartment flats to, let us say, 40 per acre, then I have brought a dramatic drop of about 40% from the norm of about 70 flats that you have per acre across the building industry. But then that is not always the solution, because market demands and dictates will suggest that they have greater density and smaller houses, because markets and prices are not something that we can govern at levels of planning. The other is that if you are therefore left with something like 70 flats to an acre, and you're left with a total gross freshwater demand of about 120,000 liters, what you can do is to see how you will address three aspects of supply side management. One is to see that you have fixed faucets and showers that drop the flow of water to as little as 4 liters per minute from the norm of about 18 liters per minute that existed, well, up until about 2.5 to 3 years ago. The new generation faucets and sanitary fittings are enabling this kind of a drop with installations called aerators or flow restrictors. They don't cost too much either if you are in the building industry. Now, with such aerators, what happens is that the flow of water to you as a layperson is much the same as it has been for all these years. But from the context of demand side management, you will see that there is a drop of very nearly 70% in the demand for fresh water. The other is that you need to see how the water that flows off your kitchens, your shower and the wash basins in the washrooms are all directly connected down. This is called grey water. Typically in the building industry, this grey water has been combined with black water that comes off your water closets. We have been advocating and practicing the separation of the grey water and the black water components from a building and trying to treat them in a way that the black water is used for gardens and the grey water is recycled on a loop for your flush tanks. The other aspect of such demand side management is to see that you harvest rainwater. Now, for every 100 square meters or 1,000 square feet of a terrace, you can harvest nearly 250,000 liters in a year. So you can imagine what you can do in an apartment block if you used all the water that falls on your terraces as well as on all the hard surfaces that flank the buildings. This means essentially that for about 3 acres, you will have about 2.5 million liters or 25 lakh liters of rainfall that can be captured and utilized with some basic treatment for purposes of fresh water itself in your apartment campus. Now, between the three, the component of demand for fresh water that reduces is dramatic. It is as much as 70%. So if you have a story where you have 120,000 liters in an apartment, you're talking of something like 80,000 liters lopped off, essentially because you have done effective, strong demand side management of these three practices of rainwater harvesting, of flow restrictors and aerators at every faucet and shower, and of treating all your grey and black water and reusing it in a mode that is not so much about recycling as much as it is about upcycling. There is, however, one other aspect apart from the three when it comes to demand side management, and that has to do with efficient landscaping architecture. As a matter of fact, whether it's the Green Business Council or other professional bodies, they're beginning to understand how indigenous plants don't claim as much water as exotic species. What does this mean? At the time you begin to plan all your planting and vegetation in the apartment or the residential project, or it could even be a commercial project, please ensure that you have had some good professional who knows how to give you water efficient species as well as water efficient irrigation systems. That's a subject that needs some delving in at a deeper level, but that's not in this context. How you manage the supply of this efficiently designed system as far as water needs go and how you bring them in. We will talk about it another time.